Good morning, everyone, and thank you for joining us for today's webinar on electrical bearing protection in water treatment. My name is Sean Clary. I am the e-marketing specialist here at Electrostatic Technology, where we manufacture EGIS rings. Our speaker is Andy Krespach, who is the National Sales Manager for EGIS rings. Before I turn the mic over to him, just a little bit of housekeeping. Firstly, everyone is muted, and you're actually doubly muted. You're muted from our end and from your end. When we will have question and answer session at the end, and when we get there, if you have a question, just type it into the questions box, and then at the end of I'll monitor those as we go along, and I'll try to pipe in as Andy goes through the presentation if you ask a tightly related question. Otherwise, the Q&A session will wait till the end. If you have a question, I will unmute you from our end, and if you want, you can unmute yourself the rest of the way and converse with Andy. All right, that's one thing, is the questions and answer and muting system. Handouts. There are a couple of handouts. We have our EGIS bearing protection handbook available for download, as well as a case study on shaft grounding and water treatment. So go ahead and download those if you're interested. The last thing, and this may just be my connection, but I was talking to Andy earlier, and he sounded a little quiet. So if that's the case, just turn your speakers on up. The clarity was still there. He was just a little bit muted for me somehow. And maybe, like I said, maybe that's just me. But if you can't hear Andy, just go ahead and turn him up. So with all of that said, I will turn the mic over to Andy.
Good morning. This is Andy Krespach, National Sales Manager for EGIS for North America. And we are here today to talk about shaft grounding, and we have plenty of examples from wastewater treatment. We do a fair amount of wastewater treatment with shaft grounding, and it is successful. So let's jump into it. First of all, Electrostatic Technology is the name of the company. EGIS is the product name. EGIS is the shaft grounding device, whether it's an SGR or a Pro Series or that kind of stuff. We're actually owned by ITW, and let's see, let me grab something here and get it out of the way. There we go. And shaft grounding is used in every market. Doesn't matter if it's electric vehicles, large or small AC, DC motors, permanent magnet, synchronous, doesn't matter. Industrial motors, everything to do with HVAC, generators, traction motors, specialty equipment. And the types of industries that we're in is just about everything. If you have motors doing something, then you most likely have or need EGIS if you're using motors. Not all the time, but it is a fair amount of the time here. And there, hang on one second. Okay, just so everybody knows, there is a 2-year extended warranty, and that warranty, if you take a new motor and put EGIS on it, register it with us, or if you've rebuilt the motor, go and register the motor with us. What that does is that gives you some extra protection. So if you had a 1-year warranty on your ABB motor, then you would have an extra 2 years against premature bearing failure when using EGIS. If you need more information, you can call us, email us, whatever it is. We'll be happy to talk through it with you. So, experts. This is where it all started. Pulse width modulation on a drive, or what's known as PWM inverters, or VFDs, have recently been found to be a major cause of motor bearing failure in inverter drive systems. Now, that was in 1998. There are many different sources out on the internet and research studies and that kind of thing. The point of this is that one of the ways that we know that electric motors fail in about 50% of the cases is by using a VFD on an electric motor. Doesn't matter who makes the motor, doesn't matter what horsepower it is, doesn't matter what the electrical requirements are, doesn't matter where it's being used. We do see this all the way across the board. And I have heard several comments from people saying, well, we do really good maintenance, so we don't have this. The fact here is that if you have electric motors and VFDs, you have this, you just haven't recognized it yet. So that's literally where it comes down to. It doesn't care what industry it's in. This will cause problems for you between VFDs and motors, and that's not the only way of actually creating problems. Why is this important? Because the cost of having motors go down prematurely is fairly high. So the bearings most often in motors are typically L10, and L10 simply stands for 100,000 hours of operational lifespan, mechanical lifespan. So after about 100,000 hours, the bearings are pretty sloppy and need to be changed out. Well, what happens when your motor fails at 2 weeks or 2 months or 2 years? It's going to cost you more money, and that the bearings in there should last 5 to 10 years pretty easily with the proper care and maintenance on them. Not too much grease, not too little grease, and then understanding what the motor, make sure that the motor is actually doing what it should be doing, and it's the right application. But as you can see, a 500 horse motor, downtime is exceedingly expensive. So the cost here really skyrockets. It's not so much the repair cost, but it's the downtime that is going to create the problems for you. So there's two types of currents that we're going to talk about. One is called capacitive EDM currents, and I'll refer to it as induced shaft voltage for this presentation, induced by the VFD, and is picked up by the rotor, acting as a capacitor, and then dissipates through the most conductive path, which is 1 or 2 of the bearings, and then also down the shaft, so you're using a gearbox or a pump or those kinds of things. The other thing we're going to talk about is high frequency circulating currents. High frequency circulating currents are not something that you see every day, but they're out there and will cause problems, and the problems look pretty much like you have VFDs that are creating problems for your motors or for your bearings. So those are the two things we're going to talk about today. Let's jump into this and let's take a look at this. Here we have a pretty standard motor. Doesn't matter what horsepower it is. Could be a 20 horse motor, could be a 10 horse, 50 horse, 100 horse, it doesn't matter. And if you take a look at the picture on the right-hand side with the black, blue, and red lines on it, if you could see electricity, these sine waves are basically what it's going to look like. So it's a pictorial representation of the sine waves. Nice and smooth. You can draw a line anywhere down through it. It all zeroes out. Motors like running on 3-phase power across the line, meaning there is no VFD in that mix. So let's do something else here. Let's take this same motor and let's put a VFD on it. It doesn't matter who the VFD manufacturer is, because all of the VFDs are, just about all of the VFDs on the market today are what are known as PWM. That's the standard of technology today, that pulse width modulation. So you can see right above the motor that's in that picture, as the drive is firing, it's trying to match the sine wave. When you're creating a little bit more energy, As you can see, those when the drive is firing, it's actually going over that sine wave. That's producing extra energy. Now that extra energy does not actually make the rotor go faster, but is capacitively coupled from the stator onto the rotor, and the rotor is acting as a capacitor. So that being the case, it's going to suck up all of these very small stray electrical charges, and it's going to capacitively couple from the stator to the rotor, and that's going to live on the rotor. And eventually, when it gets too much for that rotor or capacitor to hold on to, it's going to look for the path of least resistance. That could be the non-drive end bearing, that could be the drive end bearing, or down the shaft into your driven equipment, whether it's a pump, gearbox, any type of machinery. These electrical charges will want to take the path of least resistance. So if the path of least resistance is the drive end bearing, it will essentially burn a hole through the grease that's inside of the bearing, because and let's use Polyrex as a good example. Polyrex EM is the standard bearing grease for most bearings, and its upper operating temperature is 375 degrees Fahrenheit. The electrical charge that wants to drive through that bearing and reach the grounded housing of the motor is 1,000 to 1,200 degrees. So by a factor of 3, there is a lot more energy than necessary. And basically what it does is it burns the grease. So if you have used Polyrex, it's blue or green, it turns black. And we'll see that in a few pictures, or else let's take a look at these right now here. Let's grab some of these. Here's a good example of a bearing that has cream colored grease in it. You can see at the top of the picture, there's cream colored grease on the cage. So, and then you look at the balls on the lower portion of it, and it looks like they've been coated with mud. Well, that is grease that's being burnt and creating a problem there. So every electric motor, because the rotor is spinning, that rotor is going to act like a capacitor, and it's going to collect those stray electrical charges. Now, this could be the case where you have, say you're making non-woven fiber. You can have static charge buildup, and it will actually affect many things in your system. So grease is not a good protector. Even though it's dielectric, the electrical charge burns a hole through it, and then eventually contacts goes from the shaft to the inner race, rolling element, outer race, and then the housing of the motor, which is grounded. That path is going to create some real problems. One, it's going to burn up your grease, and eventually what's going to happen is your grease will separate. The components of the grease will separate. The components are basic, which is lubrication and the emulsifier. The emulsifier is either soap or wax typically, and what it's going to do is by keep on jamming an electrical charge through that grease, it's eventually going to break it down so the lubrication drains off. Or if you open up an end bell of a horizontal motor, you're going to see a wet spot on the bottom of the end bell where lubrication is drained out of that grease, and what's left in that is the emulsifier. Like I said, it's wax or soap. So that being the case, that's going to create a real problem, because not only are you damaging the inside of the bearing with an electrical charge, and we'll take a look at those in a minute, the grease has now gone from something that is acceptable to use in a bearing to what kind of looks like black candle wax. So it will really create some issues for you. Now, what we do know is that if I have 100 motors, line up 100 motors and we've done this, in many manufacturing plants, data centers, rocket test facilities, I mean, everything. What we find is that about 50% of the motors, when you use an oscilloscope, we can find this image on the oscilloscope at 50% of the motors. Now, that doesn't mean that 50% of your motors are going to fail in 2 weeks or 2 months. There is a correlation between the amount of voltage and how often it discharges. So the higher the voltage, and that typically is somewhere between 0 and 35 volts. We have seen it higher, but it's somewhere in that range. Typically, we'll see 10 to 15 volts on the shaft. And then you have the rate of discharge. That rate of discharge, pretty average, 15 to 18,000 times per minute. That means an electrical charge going through, burning a hole through the grease, and then damaging the inside of the bearing. The rolling element doesn't get damaged, just turns dull, but the actual outer housing or race on the bearing is going to take a beating. So by using an oscilloscope, you can actually see what's going on without having to pull your bearings out. And by using an oscilloscope, you are getting a very accurate picture of what's going on in real time. So here's a good example of electric discharge machining, EDM. So starting on the left-hand side of the oscilloscope screen, you can see where you have a few discharges, very little ones, and then it all of a sudden zooms up toward the top of the screen. That's the voltage building up on the rotor. We know that because voltage builds up slower on the rotor than the actual time that it takes for the discharge. So that's why you get an angled line going up and then a perfect straight line coming down. If you have this on an oscilloscope, what you're going to find is you will have premature failure of your bearings because they are, one, burning up the grease in there. Number two, you're actually roughing up the inside of the bearing, both detrimental to bearings. EDM, or electric discharge machining, is a fancy word for a spark that goes from the shaft to the inner race, to the rolling element, to the outer race. And the outer race is typically going to show either frosting or fluting. I'm sorry. So the frosting will simply look like a dull gray stripe in the middle of the bearing. But if you magnify it, what you're going to find is that frosted surface is just millions of points of electrical discharge have hit the inside of that bearing. And that's when you start hearing the motor have a howl to it. The second condition you can often see is what's called a fluted bearing race. And this is interesting because it actually puts a pattern on the inside of the bearing itself. And when you get to this point that there's fluting, it is really difficult to stand next to say it's a 100 horse or a 500 horse motor and have it run, because it is just, you can tell it sounds like it's tearing itself apart. So these are the two conditions. So if you do a post-mortem on your bearings, which we always say that you should do, pull the bearings out, cut the outer race open, and then take a look at what you have. If you have frosting or fluting in there, you have electrical discharge that goes through the bearings. So it's important to know your diagnostics here if you're using a scope or if you're using the cut and inspect method. Either way, one is a little bit quicker than the other. So here's a good example of frosting and fluting. And you can, let me just go back to this previous picture here. The fluted bearing picture that's on the bottom portion of this slide looks like it's nice and uniform. Well, let's take a look at this one. This one is actually fluted, and you can see in the red circle, you see three kind of muddy stripes on the inside of the bearing. Well, that's just how it starts. Here's another example. where you're going to see these lines that go across the bearing. And eventually what's going to happen is those lines will start to fill in. And then that's when you really start hearing a fair amount of noise on the inside of the bearing. We saw this picture before, but it's instructive if you think about it. Always look at your bearings. If you are sending your bearings to a motor shop, if you're sending your motors to a motor shop, make sure that you ask them to take pictures and give you a report. Your motor shop is the expert on this stuff, and we have done a lot of training with motor shops and that kind of thing to identify what's going on here. I think we have a few other pictures. Lower left-hand picture, you can see where there's fluting. This one's been running for a while because it's actually seems like it's squishing the fluting marks down. Upper right-hand picture, again, frosting. And the lower right-hand picture shows you what Polyrex looks like inside of a bearing after it's been cooked or electrocuted on a regular basis. Currently, on my email, I have a customer that sent me all the pictures, and they said, hey, we have a problem here. We started this motor up and it failed within 2 weeks, meaning it has fluting on the inside of the bearings in 2 weeks. Those are rather extreme cases. Typically, it doesn't happen that fast, but when it does, it's very frustrating. Either you better have a spare, or you better be able to fix this quickly, because if you take large motors down like this, the production line typically is not going to run very well. So cut and inspect, or actually use an oscilloscope. We sell the oscilloscope, and it works real well. We've got thousands of them out there in the field in all kinds of situations. And whenever I'm called in, I also use an oscilloscope to make sure that that we're getting the right diagnosis for that motor. You can see from these bearing pictures on the right-hand side, there's Polyrex, is that blue grease, and then behind it, that's what Polyrex looks like when it is electrocuted on a regular basis. Turns black, and then it starts draining off. So if you can solve this problem, this makes a world of difference on production uptime as opposed to downtime. So that's where we stand currently on induced shaft voltage. There are many different kinds of electrical problems that you're going to run into with a motor. You can have a situation, I think I mentioned this before, where you're producing a product that creates static, whether it's non-woven fiber or carpet or polyester, nylon, all that kind of stuff. Say you're weaving it into a carpet, creates a tremendous amount of static electricity, and it only gets worse during the wintertime when there's not as much humidity in the air. But the most common situation we see is VFDs creating these problems. There is no adjustments that you can make on a VFD that's going to help this out or eliminate it. It just happens to be the combination of the motor and the drive. And the best way to solve that is to simply use shaft grounding. The most or long-term shaft grounding devices on the market today are the EGIS. They actually, we published 200,000 hours specifically of runtime at 1800 RPM. So that's double the lifespan of the bearings. It should, so it shouldn't be too much of a stretch to figure out that you need SGRs or shaft grounding rings for your motors. And we make shaft grounding rings for every motor out there, regardless of what it is, every shaft size, from micro type stuff all the way up to, I think the largest ones we've made are 48 or 60 inches in diameter for hydroelectric. So it doesn't matter the industry. So the next thing we're going to jump into here is common mode voltage. Common mode voltage is a condition that you're going to find in motors. This is not caused by this is caused by having issues with your air gap, or having slightly more copper on one end of the motor than the other in the windings. So there's a bunch of different conditions that can cause or have the potential to cause circulating currents. These are fortunately very easy to take care of. Use an insulated bearing on the non-drive end, or use an insulated sleeve. And basically what that does is it stops that circulating current from going around. So by insulating a bearing, sleeve, or an insulated bearing, or a hybrid bearing, it literally stops that. So it will give it a path. And then you also want to use a shaft grounding ring. Next to the shaft grounding ring in this picture that's right above the motor, there's a little bottle, and it says EGIS CS015. This is a silver shaft compound. It's paint on. It has a applicator on the inside of the brush. Shake the bottle up, put colloidal silver on the shaft where the brush is going to touch the shaft, and it will do an exceedingly good job of taking care of this. One of the things that you definitely need to do, though, is to make sure that you have a decent ground. You can put shaft grounding rings, you can use colloidal silver, you can use insulated bearings, but none of these things are going to work if you don't have a active, low resistive ground. Having a ground, and you can see where we are talking about braided ground straps. Braided ground straps are basically the superhighway for taking that high frequency discharge off the shaft before it goes through the bearings, and then taking it to earth ground safely. We find that using a braided ground strap, because the vast majority of motors out there are AC or alternating current, the electrical energy travels on the surface of the wire. So what you do is you supply much more surface for that wire, and then you have a low resistive ground. So using shaft grounding will protect your motor from any type of induced shaft voltage, as well as circulating current. But the circulating current, you need to make sure that you use a insulated bearing or an insulated sleeve in the non-drive end. And what you're going to find is that we always separate the insulated bearing. We typically will put it on the non-drive end and then use the EGIS on the drive end, or vice versa. It doesn't really matter. But you don't want to put them together. You don't want to put the insulated bearing right at the backside of the shaft grounding ring. The whole idea here is to create a high frequency path for your motor. There's a lot of times that we look at problems at industry, and what we found is there is a tremendous amount of times where there's either poor connection to the shaft with the shaft grounding ring, or there is a poor connection or a high resistive connection for your ground strap, meaning you don't have a good conductive path all the way to earth ground. It is necessary to have you have to lead that energy someplace. It's not going to evaporate into thin air. So you need to make sure that you actually have that going on. With that said, we've covered induced shaft voltage and we've covered circulating current. EGIS rings come in a myriad of sizes. Whatever shaft size you have, we have a ring for it. Typically, they can be split, solid, and there's different thicknesses and different amounts of fiber depending upon what the horsepower of the motor is. Typically, 500 horse and above gets the larger rings that are in the center of the picture here, where they have 6 rows of fiber, and then the smaller ones have 2 rows of fiber in them. But if you're interested to know what you should be using, all you get to do is call us. We'll be happy to go through everything that you have specific to your manufacturing situation. There's lots of different types of shaft grounding out there, but shaft grounding is one of those things that you need to make sure you know what you're using. If you use a Hellwig carbon block, which is a fairly inexpensive and common way to do it, you have very little contact with that block after it starts running. One of the conditions you get is something called glazing. Glazing is a clear, smooth finish that is plated out on the shaft and keeps the carbon block from actually contacting the shaft and working. I can tell you that I've been involved in many situations where we've actually tested the motor with and without the carbon block engaged, and it is exactly the same. It should be dramatically different if the carbon block was working. On the other hand, EGIS conductive microfiber, we publish out to 200,000 hours of runtime, and it is not reduced in its ability to take that shaft voltage off the shaft. Here's a carbon block in action. Creates a lot of carbon dust that gets into everything, including the motor. It's not uncommon to see a brush holder jammed. These do have to be maintained on a regular basis, meaning you have to pull them off and put a new one on. And you definitely get minimal shaft contact because you only get the size of the carbon stick that is touching the shaft that's going to give you that shaft grounding effect, as opposed to using something like EGIS, which you have 360 degrees of conductive microfiber, which is highly adept at actually pulling off that electrical charge and does not create glazing on that surface to actually have the ring fail there. So it's 100% shaft contact all the way around. If you're interested, tunneling of electrons, field emission of electrons, and Townsend avalanche of gaseous ions is how the EGIS ring actually works. We have millions of these things in service around the world, and they do an exceptional job. Left-hand picture, this is a bit exaggerated. When you get a ring, it's going to be slightly, the fiber is going to be slightly long, and the reason for that is that we want to be able to allow for human error in mounting. We want to have 360 degrees of fiber at all times. And the right-hand picture is when that fiber has been run for a while, it breaks in and runs right at the surface of the shaft and does not wear anymore, unless you had a shaft that was out of round or rusted shaft, that kind of stuff. But we do publish the 200,000 hours of runtime. When you test with an oscilloscope, the problem is pretty easy to find. Left-hand picture, you can see where we have that voltage buildup and then discharge, and that's what's called a peak-to-peak reading. You can see on this scan here in the upper left-hand corner of the oscilloscope screen on the left-hand side, it says 20.2 volts, and that's a peak-to-peak reading. Then you install EGIS, and then you actually lower that all the way down to a very minimal amount. Once you do that, now you have created a situation where your bearings can last for a much longer situation there. This is a edition 3 copy. We actually have edition 4 that came out just a few months ago. If you're interested, I believe there's one actually that you can download. You can also go to our website and download it from there. But this has a tremendous amount of good information in it. So now we're going to take a look at motors. Say you have a motor where both bearings are insulated. It doesn't matter if these motors are moving liquid, air, it doesn't matter what the motor is being used for, whether it's horizontal or vertical. Using shaft grounding works, and we know it works. So if there's any situation where you're not sure, give us a call. It's not a problem. We have a full engineering department, and anybody at EGIS can actually help you out with specific situations. And if you can't get a hold of somebody immediately, just make sure you leave your name and number and we'll call you back. PDQ here. Motors with cylindrical, Babbitt, or sleeve bearings. I know there's a lot of very large motors out there with Babbitt bearings. The Babbitting is not going to be have the two conditions we saw before, but you can still see there's electrical discharge, and it will actually end up eating up your Babbitt in there. So cylindrical, roller, Babbitt, sleeve, doesn't matter what kind of bearing it is. The vast majority of motors in wastewater treatment are vertical motors, whether they're hollow or solid shaft, really doesn't matter. What you're going to find is because there's a lot of metal to metal contact in the thrust bearing, which is at the top of a vertical motor here, in order to protect that, those bearings on the top of the motor, because that's the whole rotor and everything is hanging off of that. So the thinner the grease film, the faster that energy is going to go through that grease film and create a problem there. So in the upper left-hand corner, you see a bearing carrier that has a white stripe on it. That bearing carrier has been sprayed with either Balzona or another non-conductive product. So they spray it on and then they lathe it off so that the bearings can fit specifically on the bearing carrier. Now what you've done is you've isolated the top bearing so that electrical discharge can't get through there. So now it's going to go down to the bottom, which is your guide bearing. The guide bearing is really important because it's going to keep all your vibration out and it's going to keep everything steady. But if you wear it out, it's going to be exactly the same thing. You're going to create problems for your other bearings by allowing vibration to build itself in, and then you end up replacing everything. Now this is greater than 100 horsepower. Typical wastewater treatment size pump motors, 400 and 800, pretty standard sizes. They're 100, 200, 250, 300. There's lots of sizes, but most of the time I see 400 and 800 horse vertical motors. Not to say that that's the only ones out there, but it's important. And we can actually provide a diagram for you as to what you need to protect on your motor there. So we also talked about the Pro Series, which is a 6-row ring for larger motors, typically 500 horse and up. And by the way, if you have a production motor, it's not uncommon for 400 and 300 horse to mount a Pro Series ring on there. And these are for motors that run 24/7 and they're looking to get the longest life possible out of them. So the Pro Series is a whole category of motors that we can mount shaft grounding to that motor in a variety of ways. You can see we have spacers on this one with brackets that come out, and everything gets screwed together with threaded holes so that you can mount it on the shaft, and you can see the discoloration. You see the silver on the shaft next to the ring. That is where somebody has gone a little bit berserk with colloidal silver. So colloidal silver works, use it. It's one of those things that it's micron particles of silver, and it actually is held in place by all the imperfections in the shaft, whether it's machining or pitting on the shaft, and you would have to chemically scrub it to get it out of there. So use colloidal silver. That makes a big difference. So there's lots of different types of Pro Series rings out there. SL is simply known as a slimline. It's 5/8 of an inch thick, not including the brackets and the bolts. So we can fit them into pretty small spaces. It also comes with all the mounting hardware. If you order the hardware package with it, it comes with all the different spacers, bolts, the whole works. So internal as opposed to external applications. It's important to understand that you can use EGIS either inside or outside the motor, not a problem. But you have to make sure that if you're going to mount it on the inside, you have replaced the grease seals, and you are not going to pump in, pounds of grease. It's grams of grease over a period of time, and you can go out to the internet and actually figure out how much grease you should be using that bearing over what period of time, depending upon what speed it runs at, type of bearing, and how long it runs, whether it's 24/7 or it's something less than that. The only caveat I can tell you about using an external ring is if you use them in severely dirty environments, say you have a paper mill that has a lot of fiber in it, or a steel mill that has a lot of carbon running around, those kinds of things, that has a tendency to gunk these brushes up. So we actually have brushes that have things like O-rings built into them. But if you have a dirty environment, see if you can't have your motor shop put it on the inside for you. There is a myriad of different conditions. So we produce a vast variety of bracketing and plates and all kinds of stuff specific for your conditions. We even do more exotic stuff. These are RPPR, recirculation pump protection rings. These are used typically in power plants, typically in nuclear power plants. They have 9,000 and 7,000 horsepower motors, verticals, and by using this, that actually stops things like seal failure and bearing failure. I talked just a few minutes ago about O-rings. If you can't get it on the inside of the motor in a dirty environment, you can also order it with O-rings. The O-rings are not a seal, but they're a dirt barrier, if anything. They do not turn. They are static with the brush itself, and then the shaft turns against those. There's a Pro Max. Once you get to a certain size, 15 3/4 inch, once they get to a certain size, they're not going to be as stiff as they should be. So they go to a heavier design. If you let us know what you have, we'll tell you what the best application here is for that. We also have something called Pro MR, which is a monitoring ring as well as a regular shaft grounding ring. So you can actually take off, you can see the wire at the top, you can take that and right to an oscilloscope or back to central station and get a decent reading. So a typical situation here is using EGIS on the drive end of the motor, and it doesn't have to be on the drive end, it just happens to be there's more room and availability to put it in there. So using shaft grounding, using colloidal silver, if it's over 100 horse, make sure that you use an insulated bearing. That will stave off a lot of problems specific to circulating current. And then also use a braided ground strap. I will tell you, I have customers that say, great, I'm just going to order braided ground straps. I'm not going to put a EGIS shaft grounding ring on there. Well, the energy builds up on the rotor, and the rotor and the shaft are integral to one another. So just by putting a shaft grounding, grounding strap on there isn't going to cut it. You actually have to pull that energy off the shaft and then direct it to the outside housing of the motor so it can exit with a braided ground strap. Putting a braided ground strap on without shaft grounding is of no value. Where you have both bearings that are insulated, use shaft grounding, use colloidal silver, exactly the same condition that we were talking about before. Motors with cylindrical Babbitt sleeve in medium voltage. Again, if you, whatever the particulars you have on that motor, we will be more than happy to give you the correct products for your application. Motors greater than 100 horse, vertical solid shaft motors, exactly the same thing, where you're going to be using insulated bearings and then EGIS shaft grounding. We went over this one already, and so the best thing to do is that before calling us, you take a picture of the nameplate and take a picture of the end bell of the motor so we know what we're looking at. There is a shoulder on some of the shafts that are out there, probably about 50% of the shafts have a shoulder. So if we can mount it on the shaft, that works well, on the shoulder rather. If not, we can actually extend it out. So there's a myriad of different conditions. You have the motor. Tell us what the conditions you have, and we'll make sure you get the right product for that application. DC, if you happen to have DC motors, EGIS works for DC motors just the same as it does work for AC motors. Press fit, bolt through, pretty much every kind of situation you can imagine there. John, do we have questions that they're looking for answers to?
We do, yep. Thank you, Andy, by the way. All right, our one was actually just a comment, and Larry pointed out that it seems like $1,500 to repair a 30 horsepower motor is on the low side, and you might be understating how much your system can save.
Yes, that's the problem with creating an example, is that example is only as good as the actual facts that you put in there. So yeah, it does cost a fair amount to get things repaired. Better to do it correctly to start with, and then you'll have plenty of long life out of your motor. John?
All right, thank you, Andy. The next question is from Manuel, and Manuel, I've unmuted you from our end. He said, from your presentation, the worst operating condition is to have a 6-pole drive with no harmonic compensation. No argument there, but what about a 6-pole drive with harmonic compensation complying with IEEE 519? You should expect damaging currents and voltages, but at a much lower rate. Please explain. And Manuel, you are unmuted from our end. If you want to talk to Andy, you can unmute yourself.
So as you know, what you're talking about is true, okay? You can use chokes, you can use all kinds of stuff specific to these motors. But what you're going to find is that a really small amount, typically 10 to 15% of that problem is going to be taken care of by using the devices you're talking about. You want to say you have 25 volts on the shaft. Oftentimes we can get that down to just 1 or 2 volts. Say you have 10 volts on the shaft, we can get it under 1 volt. And that's really what you want to do, is you want to bring the voltage down far enough so you don't create a problem. But when you use things like chokes, what's going to happen is, say you have 10 volts on the shaft, it'll take out 1 to 1.5 volts specifically. And the result here is that you're still left with 8.5 volts on the shaft. Well, if that's the case, you're still going to get some sort of discharge. Will it last longer? Yes. But the whole idea here is that if you paid for an asset like a 500 horse motor, which is about, well, just roughly, we'll say it's $50,000, you want to be able to maximize the use on that motor. And by using shaft grounding, which is completely accepted, and there's nothing wrong with using chokes at the same time, that kind of thing. But it's important to understand that EGIS will take out the vast majority of that electrical discharge, whereas using the products that you're talking about are only going to take out a small amount, that 10 to 15%. If that's the case, and you have lowered it down far enough, and that's acceptable for you, fine. But what we try and do is we try and get out to the longest operational time possible with shaft grounding. We know that our brush will survive just about any type of situation, but we want to give you the best bang for your buck there. Sean?
Thanks, Andy. The next question is from Scott, and Scott Lucas. I will unmute you from our end. And Scott asks, for an existing 300 horse vertical motor, is there a benefit to adding an EGIS ring if the motor does not have an insulated bearing?
Any motor that is over 100 horse, and this is the directive. You can go back to the motor manufacturer and ask the question too: do you need to protect the motor against circulating current? And the answer is yes. Whether you have it or don't have it, you can't actually test for it. You would actually have to drill holes in the outside housing of the motor and then test your voltage on one end of the motor and the other end of the motor. So best thing to do is just put yourself in a position where you use shaft grounding. And if you have a 300 horse motor that has the bearing carrier up on the top, make sure you're also using or have it done for you the insulating products that keep everything safe. Sean?
Thank you, Andy. And that, believe it or not, that was actually the last question.
Hey, Andy.
Yes.
You still? If my question was if you don't have that upper insulated bearing,
Mm-hmm.
or you're using some type of product to insulate that upper bearing, does it still benefit you to add that EGIS grounding or shaft grounding on the other end?
Are you saying that if you don't have an insulated bearing on the top end?
Yep, this would be a vertical motor, or hollow shaft type motor, and mm-hmm. I don't know if the motor has the insulated bearing, but say if it doesn't, mm-hmm. is there a benefit to add the shaft grounding ring? Is just protection, or it doesn't do you any good?
It is beneficial there. So say you don't have it. The two conditions we're talking about is induced shaft voltage and circulating current. So those two things, you can 100% stop circulating current by having a insulated bearing on the top end, or yes, insulating that bearing in some way. But there are plenty of situations where the voltage is low enough, doesn't really create too much of a problem. Using EGIS shaft grounding will pull off anything that's on that shaft as far as electrical discharge. So yes, you can. It's not an issue. And I run into this all the time where people are like, well, I don't want to insulate my top bearing. I'm like, okay, but we're talking about the belt and suspenders type application here. We want to make sure we got all the bases covered so that you don't have these types of issues moving forward on your production line.
Yeah, that was just a question. We've got an existing motor that's been in a while, and if it's a benefit, we can get that grounding ring added. And then also we have a very good grounding system in most of the buildings that we have, and we just bond each motor to a ground ring. Is that adequate? The motors are very well grounded. Do we need to have that shaft or the braided strap also?
So if we look at everything in kind of a percentage, okay, if you have just a motor and it has shaft voltage issues, and then you use a EGIS shaft grounding ring, it'll work fine. If you have that shaft grounding ring in colloidal silver, you're going to drop that voltage down. That brush will work just that much better by using colloidal silver.
Okay.
Then by having a braided ground strap, that's really, is it going to create a eureka moment like, wow, I solved it by using a braided ground strap? No. I would say that the braided ground strap is probably the least expensive of any of the things that we're talking about here. And by using braided ground straps, it just gives you a super highway to get that voltage off the motor and discharging to earth ground. And by the way, your ground is based upon ohms of resistance, okay? So we're between some like 5 ohms of resistance or less is a very good ground. But if you had 50 ohms of resistance on that ground, you would not know that you have 50 ohms of resistance unless that was measured. So using shaft grounding and using colloidal silver and using the braided ground strap, you're covering all the bases.
All right, thank you very much.
Absolutely. John?
All right. Thank you, Andy, and thank you, Scott. We actually have another question from another Scott. Scott Smith, I'm unmuting you from our end, and he asks, if a motor is rated for inverter duty, are any of these best practices, these precautions, already taken in the factory?
That's an excellent question. And let me give you a description of inverter duty motors. Inverter duty motors refer to heat dissipation only. When you have an inverter duty motor, what they do is they use a cast iron housing or cast iron end bells, and they also use F-class insulation on your windings, which is typically like the color of dark chocolate. That refers to heat, because if you are running a motor at 1800 RPM, the fan inside is turning, it's keeping the motor cool. Well, what happens when you slow that motor down to 1800, say you slow it down to 900 RPM, but you're working the motor just as hard? The amount of heat that builds up on the inside of the motor is substantial. So they went to F-class insulation because it's more of a heat-resistant winding coating. And then cast iron, like I said, is a better dissipation of heat. So that's why they use typically cast iron end bells or the actual case of the motor. Will it do anything for shaft grounding? Absolutely not. If you have electrical energy building up on the rotor and dissipating through your bearings, it's not going to solve that unless you use something specifically for that, which is using shaft grounding. Something like EGIS shaft grounding will take the vast majority of electrical energy off of your shaft before it gets a chance to go through the bearings, and then take it out through to earth ground. this is a real, this is a question I get almost every week. People will say, okay, do we have, this is an inverter duty motor, but it's still failing. And I hear this a lot. Well, the fact here is that inverter duty motors are gonna be just the same as any other motor out there, unless you use shaft grounding.
Okay,
Sean?
yeah, thank you for that. So basically that inverter duty takes care or addresses a different issue that VFDs may introduce to a motor, not necessarily the grounding issue.
Correct.
Or
And
not the grounding issue at all.
it is important to understand that if you're using, say you're using just a standard motor, and you're using it on an inverter, can you heat up the windings and that kind of stuff? Yeah. F-class insulation is pretty standard on motors now, but you want to do what's correct for that motor. If you have shaft grounding issues, make sure you're using EGIS shaft grounding on there with colloidal silver and a braided ground strap, and then you don't have those issues and you can protect yourself into the future there.
All right, thank you.
You bet. Sean?
Thank you, guys. Got one more question from Victor. Victor, I'll unmute you from our end. Victor asks, what motor manufacturers offer grounding ring installation at the factory?
Just about all motor manufacturers are offering EGIS shaft grounding, and then others, and then other types of shaft grounding. So the only company that I know of right now, Siemens, is difficult to work with because they're like, no, we don't need it, even though their motors are failing, and their customers call us and say, look, what do we do here? And so the idea here is just about everyone has motors, not all of their motors, but just about every motor manufacturer has a selection of motors that have shaft grounding already built in. You do need to check that, and you can't just say shaft grounding because as we looked at before, you have carbon block. I mean, there's a whole bunch of different types out there. There is no shaft grounding product that will work like EGIS works long term. We've perfected that. That's how it was designed. And the idea here is to use the products that are going to give you your best solution for your motors. Sean?
Andy, that's it.
Okay. Thank you for your time today. Appreciate all the questions, and happy to answer any questions if you have. If you want to talk to us directly, Sean has put that information down in the sidebar. We will welcome your questions. Thank you.
Yep. Right, Andy mentioned that I put our email address in the chat box, so you can get those out of there, or you can, if you reply to, I'll get those for you. Last thing, I want to remind you that there are the couple of handouts in the handout section, our bearing protection handbook and the water case study. So I'll leave the webinar running for just a couple more minutes to give anyone who wants to grab those time to do so.